what I got out was the test from chapters 5, 6, 8.1 and 8.2, and even 8.3 and 8.4. Doggone it, why am I having trouble here? Which looks like this. The first problem on it was 40 degrees, 47 minutes, plus 86 degrees, 40 minutes. Now, here's what I would do if I were you preparing for the final relative to chapters 5, 6, and 8. I would make sure I could rework this test, and the problems on the test that you need to know how to do are 1 through 17, which happens to be all of this test. So, am I suggesting that you go back and rework every single one of these problems? Yes. I would work them until I could get them. And if you do that, and you do everything I happen to mention parenthetically as we move through some of these problems, then you should be in pretty good shape on the final. So, what I say, all 17 problems off of the test for chapters 5, 6, and 8. Now what I have done is I've gone through the test and picked a few problems for us to work together. The ones I picked for us to work together aren't really designed to get you ready for the final. They're designed to get you ready to go back and work the 17 problems on this test. The 17 problems on this test are designed to get you ready for the final. You see the difference? So don't think that if you're good on these 17 problems, then that means you're good for the final. You're not ready for the final until you can do all 17 and check them and be right. Okay. Now, the first problem I picked out for us to work together is number 7. But now I don't think that that's all that important for us to work, because if you look at number 7, it is just exactly like one of the problems that we just did to get ready for your chapter 7 test. It's like find sine if you got cosine given to you. Okay, so we just did a problem like that. You can either use an identity or a triangle now. The next problem I have picked out to look at together is number 11. So let's go there. Number 11 has convert the radian measure to degrees. We have negative 5 pi over 2 radians. Now I don't see right offhand the vice versa of this problem, convert a degree problem to radians, but I could ask you for that too. But to convert radians to degrees, we multiplied by 180 over pi. To convert degrees to radians, we multiplied by pi over 180. Make sure you can do both. Okay, so here the pi's cancel. 2 cancels with 180 and makes 90. And negative 5 times 90 is negative 450 degrees. Okay. I also had the very next problem picked out for us to take a look at. Number 12 says sine of s is equal to negative root 3 over 2. But this time we're put on the interval from pi to 3 pi over 2. So it's just a unit circle problem. You have to know where sine is equal to negative root 3 over 2 on the interval from pi to 3 pi over 2. And the answer here turns out to be 4 pi over 3 radians. Remember, if you've got an S, you're in radians. Now you kind of knew that in this problem anyway, because they put you on an interval from pi to 3 pi over 2. I also picked out number 13. Says find the value of s on the interval from 0 to pi over 2 that makes the statement true. And it has sine of s equal to, holy cow, that's a long decimal, 0.632999623. And again, you know that you're in radians here because you got an s. So make sure your calculator is in radians. That's the point of this conversation. If you sine inverse that number in radians, you get approximately 0.6854 radians. So those problems shouldn't be tough. Just we have to be careful to make sure that we're in radians when we need to be in radians and degrees when we need to be in degrees. Okay, I also picked out all 4 of the problems on the last page for us to look at for different reasons. Number 14 was a arc length problem. It says find the length of the arc intercepted by a central angle theta in a circle with radius r. In this problem they gave us a radius of 45.39 and a theta of 13 degrees. So the formula for arc length, which you'll have to know, is S is equal to R times theta. But to use that formula, your theta has to be in radians. And that's really why I picked this problem here. So S is equal to 45.39, which I just messed up. It's equal to 45.39 times 13, which has to be converted into radians, which would I would convert by multiplying by pi over 180. And on this problem it said to round to the nearest 1 decimal place, and if you do that, you end up with approximately 10.3 if you do the multiplication here. Okay, and I chose number 15. And this was the problem that asked you for amplitude, period, phase shift, and vertical shift. Let me pause for a minute. I'm going to look at something here. Okay, so the amplitude here, the formula with absolute value of A, which in this case is the absolute value of -5, which is 5. The period for the sine or a cosine function is 2 pi over k, or 360 over k if you're in degrees. What's the k here, Natalie?
30.
That's right. So we have a period of 2 pi over 3 radians. We have a phase shift of negative c over k. And the c is the other number in the parentheses there, in this case -1. So negative c would be -1 over k would be positive 1/3. And then the constant gives you the vertical shift. So in this case, it's up 4. So certainly I want you to be familiar with how to find all of those things. However, I'm going to tell you that on your final, there's a problem that asks you to graph a trig function. And we graphed a few of these in our homework, but you didn't have to graph any on that test. So let's say you had y is equal to -2 cosine, let's say 4x. Okay, so here's the way we handled this when we were dealing with this in class. We generally went from 0 to 360 in both directions. And we started with the parent graph, which in this case is cosine. So if you forget what the parent graph looks like, just think this way. Cosine at 0 is 1. Cosine at 90 is 0. Cosine at 180 is -1. Cosine at 270 is 0. And cosine at 360 is 1. So it has to be doing that. So if it's a sine graph, we would start with sine of those 4 values. And we know it's periodic, so we know it's going to repeat on the other side of 0. So it looks like that. Okay, then I encourage you to adjust for the period. And we know that the period is 2 pi over k, or 360 over k if you're in degrees. So in this case, the period of this function would be 360 over 4, which is 90. So where I used to be going from 0 to 360, now I'm going from 0 to 90. So that means this value is going to be halfway to 90. That's going to be at 45. Where 90 was is going to be half of 45, which is 22.5. And then 270 would be 22.5 plus 45, or 67.5. Of course, you could just divide all 4 of those values by 4 and get the new values. So back here you have -90, -67.5, -45, -22.5. Okay, and then you got to adjust for the amplitude. Now this one adjusts to 2 instead of 1s, and not only that, it's also going to flip because it's got a negative. So look, I'm going yellow now. This point, which was at 1, is now going to flip down here to -2. Point at 0 stays at 0. The point down here that was at -1 is now going to flip up here to +2. This one stays at 0. This one's going down here to -2. So this half of the graph back here now is doing this, and then this side's going to repeat it. So my actual answer will be in yellow. So that's really why I wanted to mention that graph, is that amplitude, period, and phase shift problem, is because I wanted to talk about the graph. Now you could always do that on your calculator. So now finally looking at 16 and 17. Now if these are right triangles, we can use SOHCAHTOA. But if they're not, we're either going to have to use law of sines or law of cosines. Well, in this problem, we're told, I'm going to get my triangle out here, A, B, and C. We're told the angle A is 94.9 degrees. We're told little a is 31.8. And that little b is 15.2. So we're not told anywhere that we have a right triangle. So we can't use SOHCAHTOA. We do have an angle in its opposite side, so that's going to allow us to use the law of sines. If it's the law of sines, I have to ask the question, is this the ambiguous case? The ambiguous case was side, then angle. And notice, I've got side, then angle. That's exactly what I got. So this is the ambiguous case. So we're going to have to figure out if there's 0 triangles, 1 triangle, or 2 triangles. So let's see how that's going to flesh out. So if we try to set up the law of sines here, we'll have 31.8 over the sine of 94.9 equal to 15.2 over the sine of B. Okay, if we cross multiply here and then divide, pause. Okay, so first thing I need to think about here is I just did a problem a few moments ago in radians, and this problem I need to be in degrees. So let's make sure our calculator is in degrees. Don't forget to check that periodically on your test. So if I take 15.2 times the sine of 94.9 and then divide that by 31.8, I get 0.4762 for the sine of B, which tells me that there is at least one triangle. Because remember, if there was no triangle, we would get a number here that is either smaller than -1 or bigger than +1. We would get an impossibility. And so if you sine inverse 0.4762, you get 28.4. Okay, now that tells me that this angle up here is 28.4 degrees, but it doesn't tell me whether there's 1 or 2 triangles, so I have to assume that there's a second one. And remember, the second one's going to be labeled the exact same way as the first one. So this angle's still 94.9. This side is still 31.8. This side down here is still 15.2. But now remember, we assume that angle B on this triangle is 180 minus 28.4. And if you figure that, that's 151.6. Okay, now we're going to try to finish off this second triangle then. And to do that, I would figure angle C next. But you can see that 151.6 plus 94.9 adds up to more than 180, which tells me there isn't a second triangle. There's only one triangle. It's this triangle, and now we have to finish it. To finish it, 180 minus 28.4 minus 94.9 is 56.7 degrees. And now I can get little c over here by doing the law of sines again. So I could do c over sine of 56.7 is equal to 31.8 over the sine of 94.9. And if you do that, according to my calculations from days gone by, you'll get 26. So there's you a little crash course on the law of sines.